This is the last subtopic in a second chapter. The name of subtopic is Types of Yarn. Loy, Poy, Moy, and Foy. After understanding each spinning system and their advantages, their disadvantages, passage of material through each machine, now it is the time to understand the type of yarn oblique filament created due to the change in the speed of drawing rollers. In this figure, filaments are extruded, cooled. These filaments then stretched multiple times with the help of drawing in roller. Here, filaments are stretched and wind on a spool at the speed of a winding drum. Winding drum, when rotate, the spool which is present above the winding drum also rotates with the same surface speed, and hence the yarn winding takes place. This winding rate of yarn onto the spool is equal to the speed of winding drum. The process where yarn stretches multiple times is called as drawing process. This drawing action is taken place with the help of draw rollers. Filaments are passes over and under each of the draw rollers as shown in this figure. You can now able to see once filaments are extruded, these are bunched together and they passes under the first roller and then over the second, then under the third, over the fourth, etc., etc., and ultimately gets wind onto the winding package. So let's understand the drawing process in detail. In this figure, you will able to see the different drawing rollers 1, 2, 3, 4, and 5. These are the 5 drawing rollers are present in the zigzag fashion, and filaments are passes over and under each of the drawing roller as shown in this figure. The filaments are passes under the first, over the second, under the third, over the fourth, and under the fifth, and ultimately passes over the guide roller and gets wind onto the winding package. Once filament passes over the last drawing roller, it is guided by the guide roller and ultimately these gets wound onto the spool or winding package. These winding package are kept rotating with the surface contact with a winding drum. As winding drum rotates, winding package also rotates with the same surface speed. In our example, the winding drum rotates at about 4000 meters per minute. This is the rate of winding. When you see neatly, you will observe that each drawing roller is rotated at a different speed. These drawing rollers, when you observe neatly, closely, you will observe they are rotating at a different speeds. The first roller has a speed of about 100 meters per minute. This is the speed of a first drawing roller. The second roller has more speed than the first one. Similarly, third roller has more speed comparatively second roller. Fourth roller is also moving faster than the third roller. So, extruded filaments first touches to the first drawing roller and it gains the speed of 100 meters per minute. Initially, the extruded filament has a thickness as shown in this figure. So thickness is like this thickness, and the length of that filament is very small, right? As filament passes over the second drawing roller, it stretches. So you can see here the filament passes over the second roller and ultimately stretches. So this stretch causes increment in the length, right? And similarly, this stretch also reduces the diameter. As filament passes over the second drawing roller, it stretches more, and now its length is increased but diameter decreases. In continuation of that, the filament further passes under the third drawing roller. It stretches more relatively the previous one. Its length increases and the diameter reduces. In conjunction with this, when filament passes over and under the third and fourth roller, it stretches multiple times and its diameter reduces further. Now the length increased by the stretching the filament is 40 to 50 times to its original length. This can be calculated by the draw ratio. Now let's understand the structural changes takes place inside the filament when filament stretched by these drawing rollers. In this figure you can see that extruded filaments has a random orientation. These are the polymeric chains in this particular extruded filaments. These are placed like this. These are randomly placed or randomly oriented, you can say. As further stretching happens, these polymeric chains are aligned to the axis of fiber. Now you can see from this to this stretching takes place, and now this polymeric structure is now converted into this polymeric structure. So somewhat these polymeric structure try to align themselves to the axis of a fiber. They orient more and more as the draw ratio increases. So further you stretch the yarn, then the polymeric chain present in this form is again oriented to the axis. So orientation improves. So higher the stretch, higher will be the orientation. So now in the last step, the yarn is, or the filament is stretched more so that the polymeric chain present in this yarn stretches completely, and the random structure of polymeric stretch is now converted into a aligned, oriented form. Now you can see that these are nothing but the molecular arrangement. Spinning ratio or draw ratio means it is the ratio of a speed between the winding drum and extrusion. In our example, winding speed is 4000 meters per minute and extrusion speed is 100 meters per minute. The draw ratio is 4000 divided by 100 and it becomes 40. Higher the draw ratio, higher will be the molecular orientation, and higher orientation gives a better strength to a filament. Winding speeds decides the orientation of a polymeric chain in the filament. The different rate of a winding produces the different molecular orientation and hence different types of yarn. There are 5 different types of yarn can be created. Only difference between them is a molecular orientation. Lower winding speed, that is 1000 to 1800 meters per minute, causes a lower stretching, causes lower molecular orientation. Such a yarn is called as LOY, that is low oriented yarn. The low oriented yarn can be created by keeping the winding speed at 1000 to 1800 meters per minute. In that case, you can see the first draw roller speed and you can see the winding speed. There is not such a big difference between them. So yarn is not stretched multiple times, and hence the yarn whatever we are getting it at the spool or winding package, it has a molecular structure like this. These are not stretched. So yarn though, so the molecular chains in the yarns are randomly placed. The orientation is very low in between them, but they are having a capacity to stretch multiple times to their original length. Now let's talk about the medium winding speed. The when we keep winding speed at the medium rate, that is 1800 to 2800 meters per minute, causes the medium stretching, and that causes the medium molecular orientation. Such a yarn is called as MOY. MOY stands for medium oriented yarn. So to produce a medium oriented yarn, a winding speed has to keep at 1800 to 2800 meters per minute. Medium winding speed, that is 1800 to 2800 meters per minute, causes the medium stretching, and that causes the medium molecular orientation. Such a yarn is known as MOY, that is medium oriented yarn. Why this medium oriented yarn is called MOY? Because their molecular orientation is somewhat in the middle. So like this, you can see in this figure, this is the molecular orientation that we are going to get it once yarn is prepared. So you can see this is the same speed. You can see this is the same speed as of your the first roller having the same speed, but the winding roller speed changes. It now becomes 1800 to 2800 meters per minute. That means the winding rate is higher. That means stretching is higher. Higher stretching causes this structure. Let's talk about the next type of yarn. Moderate oriented yarn, or sometimes it is also called as a partial oriented yarn. This partial oriented yarn is created when the winding speed is in between 2800 to 4000 meters per minute. At this speed, moderate stretching takes place, and that moderate stretching causes the partial molecular orientation. Such a yarn is called as POY. In this figure you can able to see that winding speed has now been increased comparatively the LOY and MOY. This winding speed is around 2800 to 4000 meters per minute. When you increase the winding speed and drawing in roller speed, you can see the first drawing in roller has the same speed as that of here MOY and LOY, but the winding rate and all other drawing in rollers, their speeds are changes relatively higher. So higher winding speed causes this molecular structure to orientate partially, and that's why this yarn is called as partially oriented yarn. So let's talk about the next type of yarn. The next type of yarn is HOY, named as high oriented yarn. Now in our case, when we increase the winding speed furthermore in between 4800 to 6000 meters per minute, so in that case you can see winding speed has increased relatively POY, MOY and LOY. You can see easily winding speed has increased. Similarly, the drawing in speed also increases. So what has happened to this yarn? Now the molecular chains in these yarns are more oriented to the axis of a fiber relatively to POY, MOY and LOY. You can see clearly this molecular chain arrangement is somewhat oriented to the axis, right? And this is happen because of higher stretching takes place at the drawing process, and winding takes place at a higher speed, is about 4000 to 6000 meters per minute. Now let's talk about the last type of yarn, is nothing but FOY, that is fully oriented yarn. Now in our case, the speed, when we keep at the speed at which winding drum rotate, is all about greater than 6000 meters per minute. You can able to see the winding drum is rotated very fastly relative to HOY, POY, MOY and LOY, right? LOY winding rate is very small. MOY winding rate is relatively higher. Then POY winding rate is comparatively much higher. And then the high oriented yarn has a winding speed of about 4000 to 6000 meters per minute. But in our case, that is FOY, that is fully oriented yarn, the speed of winding drum is greater than 6000 meters per minute. In that case, stretching is much higher, and higher stretching causes the polymeric chains to orient themselves, align themselves to the axis of a fiber, and in that case highest orientation can be obtained in case of fully oriented yarn. So by the time now you can understand the difference between LOY, MOY, POY, HOY and FOY. Let's differentiate these different types of yarn. The distinguishing factor is as shown in this figure. You can see these are the parameters and these are the type of yarns. So let's compare each type of a yarn in detail. Based on the delivery speed, we can say LOY requires 1000 to 1800 meters per minute, MOY requires 1000 to 2800 meters per minute speed, 2800 to 4000 meters per minute is required for POY, MOY requires 4000 to 6000 meters per minute winding speed, and FOY requires greater than 6000 meters per minute to produce these types of yarn. Talk about the orientation of molecule. You can see in earlier slide that how orientation of polymeric chains takes place in each type of yarn. So orientation of a molecule is low, you can say randomly placed in the LOY. Similar placement takes place in the MOY too. So partial orientation takes place in a POY, whereas medium orientation takes place in a MOY, and highest orientation can be possible in case of FOY. This orientation of a polymeric chain from low to high is possible due to the higher winding speed. Now let's talk about the elongation at bake. Once you create this type of yarn, you can elongate this type of yarn 2 to 300%. That's its original length. That means if you take 1 centimeter of LOY yarn, you can stretch that 1 centimeter to up to a 3 centimeter length, right? So it has highest stretching ability. In case of MOY, the yarn can be stretched up to 150 to 200%, right? That is 2 times its original length. That means if you have 1 centimeter yarn, you can stretch this yarn up to a 200 up to 2 centimeter, right? So it is twice as much as its original length. You can stretch, but it will not still break, right? Next, in case of a POY, it can stretch up to 100 to 120%. That means 1 centimeter of POY yarn can stretch up to you can say 1 centimeter plus again 0.5 centimeter extra. So similarly, MOY yarn has a 50 to 80% stretchability. Similarly, in case of FOY, stretchability is much less. That means the FOY yarn is not stretched multiple times like in case of LOY. Yarn has its ability to stretch it to a multiple times its original length, but POY yarn has not that kind of ability. It cannot stretch more than 5 to 20% than its original length. Okay, next differentiation point is all about a shelf life. Shelf life is nothing but uh, when you create this type of yarn, let's say LOY yarn, it can preserve the properties of yarn up to 1 to 2 days, right? So when you exceed 1 to 2 days, you can keep this yarn as it is. Up to 1 or 2 days, you cannot do any kind of processing on it. It will lose their properties, right? So the shelf life is nothing but the time, or in the form of days, how many days that yarn possesses their original properties, right? So 1 to 2 days shelf life. After 1 to 2 day, yellow Y loses their properties of stretching, you can say, right? Now in case of MOY, the shelf life is greater than LOY, that is 2 to 5 days. In case of POY, it is 1 to 2 months. In case of MOY, it is 2 to 3 months, and in case of FOY is a lifetime. That means the shelf life, you can keep the FOY and as it is for your lifetime. It will not change its properties. So let's talk about the POY yarn. This POY yarn is generally used for texturizing purpose. So to make a yarn textured, POY requires this much amount of elasticity or elongation at break. If it exceeds to, if it, if we keep this POY yarn 1 to 2 months and then utilize for texturizing, it loses all its properties. So it has to be used before 1 to 2 months, right? This is the meaning of shelf life. Now let's talk about the different type of region present in the each type of yarn. So the amorphous region, you can say these are the higher in the number in case of yellow Y yarn. Amorphous regions are more comparatively crystalline region in case of MOY yarn. Amorphous regions are dominating comparatively crystalline region in case of POY yarn. But in case of MOY yarn, crystalline regions are higher relatively to a amorphous region. Similarly, in case of FOY yarn, crystalline regions are much higher in the FOY yarn, right? So overall, you can say who is having highest strength. Highest strength can be possible if number of crystalline regions are higher. So FOY yarn has the ability to have a higher strength. But if someone wants a higher elongation, in that case yellow Y yarn is suitable, because yellow Y yarn has 200 to 300% stretchability. So highest stretchability can be possible by yellow Y yarn, and highest strength can be obtained through FOY yarn. So let's talk about the each type of yarn in summarized format. So LOY yarn. LOY stands for low oriented yarn. Low oriented yarn are produced at the speed of 1000 to 1800 meters per minute, which is having more amorphous region. They are having lower molecular orientation, and the shelf life is around 2 to 3 days. Next type of yarn is medium oriented yarn. In that case, the medium oriented yarn are produced at the speed of 1800 to 2800 meters per minute winding speed, which is having a moderate amorphous region, moderate molecular orientation, and have a shelf life of 3 to 5 days. Talking about POY, that is partially oriented yarn, these are produced at the winding speed of 2800 to 4000 meters per minute, which is having the lowest amorphous region, or you can say medium amorphous region, more molecular orientation, right? And this can have 100 to 120% elongation at break, better shelf life relative to P relative to LOY and MOY. These are generally widely used in this industry because these yarns, that is partial oriented yarn, has an application in case of textured yarn manufacturing. The next is highly oriented yarn. That is, high oriented yarn are produced at 4000 to 6,000 meters per minute winding rate, which is having a more crystalline region, that is more molecular orientation, and has a better shelf life and can directly be used for other processes like weaving, knitting, etc. And last not but the least is fully oriented yarn. Fully oriented yarn are produced at the speed more than 6,000 meters per minute of winding, and which is having highest crystalline region of about 90 to 98% and having a higher molecular orientation and can be directly used for further processing. It has extremely better shelf life. So at the end, I can say that these are the different types of yarn can be created by just adjustment in the winding and drawing in rollers speed. So there are basically different types of yarns, that is LOY, then MOY, POY, HOY, and FOY. According to the requirement, one can produce these different types of yarn on the same machine just by adjusting the speed of drawing in roller and winding drum speed.